Hi class, this is Neil, and this is lesson 3 of Unit 9. In this lesson, we're going to be introduced to the unit circle, and we're going to really figure out how we can apply our knowledge of reference angles, which we learned about in the last lesson, to extend the use of trigonometry functions for all values of theta. So we're going to see that there are trig functions for all possible angles. All right, so let's take a look at the two questions in the do now. So in question 1, we're told that a circle centered at the origin has a radius of 109 units. We know the terminal side of an angle, theta, intercepts the circle at point P as shown below. And I know the y-coordinate of the point is 60. Okay, I don't know the x-coordinate, so I'm going to make a note of that. All right, so I'm going to label the parts of the circle and the parts of this triangle that I'm given in the problem. First of all, I know the radius is 109 units. So the radius is really that distance from the center to point P. So that's 109. I also know that the y-coordinate of point P is 60. I don't know the x-coordinate, so I'm just going to indicate that with an x. My y-coordinate is 60. Now, from the last lesson, we took a look at a few problems where we're just given points, and those points tell us something about the triangle. The y value is the vertical distance from the x-axis to point P. So I can label that side of the triangle with 60. Now, before we kind of dive into part A, writing a ratio that represents cosine of theta, let's go ahead and figure out what this last side of the triangle is, the side that we don't know anything about. And the way I would find out the length of that last side is just using the Pythagorean theorem. So that's a squared plus b squared equals c squared. Now remember, c is always the length of our hypotenuse. Our hypotenuse here is the same as our radius, so that's 109 squared equals, now a and b, it doesn't matter where I put those in the equation, but I'll go ahead and label 60 as side a, so that'd be 60 squared plus side b, which is our unknown, our x value, that is going to be here, x squared. So our equation reads 60 squared plus x squared equals 109 squared. All right, so when I input these values into my calculator, I would get 3600 plus x squared equals 109 squared. I don't know off the top of my head, so I'm going to go into my calculator, put 109 squared, and that gives us 11,881. Okay, I'm going to subtract 3,600 from both sides. I'll get x squared equals, all right, 1181 minus 3,600. So 8281, and now I need to find the square root of that to get x. All right, we have 91 is equal to x. All right, so x is the value of our x point but that's also the side length that runs along the x-axis. So 91 is that side length. It's also the value of x here. Okay, so now we're kind of ready. We have enough information to attack the next two parts of the problem. All right, so we need to write a ratio that represents cosine of theta. Now I'm going to just label my triangle based on where that angle theta is. So there's the location of theta, meaning the side opposite is 60, the hypotenuse is 109, and the adjacent side is 91. Okay, so remembering our three ratios, we've got SO, CA, TOA. What we're interested in here is cosine. So that's the adjacent side over the hypotenuse. So I can write cosine of theta equals 91 over 109. Great, so we've done part A. All right, for part B, we're asked, to the nearest hundredth of a degree, determine the value of theta. All right, so here we're going to use inverse cosine. So I'm going to write the equation that I really wrote for part A to start off with. And now to both sides of that equation, I need to take inverse cosine. So that's that cosine -1, cosine -1, and I'll get theta equals inverse cosine of 91 over 109. So that means that theta equals, and again you have to turn to your calculator here, all right, I'll write it up at the top. So remember that's in the functions menu. We do want to make sure we're set to degrees first. So functions, cosine of -1 of 91 over 109. And we get that that angle measurement is 33.398. To the nearest hundredth, that would be 33.40. All right, and I'll just circle that or highlight it. Highlighting it might make it easier to see here. So that's the answer to part B. All right, so pause the video if you need to take those notes down. All right, moving on to question 2. Sketch each angle theta in standard position. So we'll talk about what that means again in a second. Draw and state the value of the reference angle R for theta. Okay, so to do this, we need to kind of remind ourselves, what does standard position mean? Standard position means that we're starting from the positive x-axis and then rotating our angle around the coordinate plane counterclockwise. So I'm going to label some guide angles. They're also called quadrantal angles. I'm going to just label those around my coordinate plane here for this first one. So we end up 0 and 360 are the same, just as a point of reference. Okay, so 165 I know is in between. That's my first angle here. 165 is somewhere between 90 and 180. It's closer to 180. So I'm going to sketch that angle approximately where that is, 165 degrees. Okay, I'm going to indicate the initial side where I started at. I always start at 0. And now I rotate all the way around to to 165. Now that's my angle theta, and we're told here theta is 165. Okay, so our reference angle R is the distance between that angle and the x-axis. The angular distance, I should say. Okay, to calculate it for this problem, we would just take 180 and subtract 165 from that. Okay, and we get a reference angle of 15. So there is that angle R. Make sure you indicate it with an R. And our reference angle here is 15 degrees. Okay, for the second problem, sketch theta equaling 190. All right, so if we need to, we can draw in our quadrantal angles or our sort of guide angles. Okay, so my initial side, of course, is the positive x-axis. And now I need to go all the way to 190 degrees. Well, 190 is somewhere between 180 and 270. It's much closer to 180. So I'll sketch my angle in here. I'm going to indicate how I rotated that angle, which is this way. So that's my theta. And theta here was 190. Okay, finally I'm going to indicate my reference angle. Now, again, the reference angle is the distance between the terminal side and the x-axis. In this problem, that's that little bitty distance here. So that's my R. To calculate the reference angle, I'm going to take 190 and subtract 180 from it, so I get a 10-degree reference angle. Now, it's important really to note that I could also just look at this and see that if I was at 180 and I had to go to 190, I would be traveling 10 more degrees. All right, so for the last problem in question 2 of the Do Now, theta, our angle is 322 degrees. I'll draw in my quadrantal angles. Okay, so 322 is somewhere between 270 and 360. It's a little more than halfway in between the two. I'm going to sketch the initial side of my angle. Now if I go all the way around to 322, somewhere around there, that's theta. So theta equals 322 degrees. Now the reference angle, R, is the distance between that terminal side and the x-axis. So one way to calculate it would be to say, all right, I've traveled 322 degrees out of 360 degrees. So I really have 38 more degrees to go until I'm all the way around the circle. So our reference angle here is 38 degrees. We could also kind of look at the distance between that terminal side and the initial side and see that the distance we need to travel is 38 degrees. All right, that is all for the Do Now. See you in a future video.